Hello, we're back. We're going to continue our series on geometry, this time with angles. Well, what are angles? Well, let's look at this drawing. It looks like it's two rays connected at an endpoint, which is what they are. There are two rays connected at an endpoint. Endpoint. So, how would you call them? How would you name them? Not how would you describe them, how would you name them? So you'd name them with their endpoint, a point on one ray, and a point on the other ray. And it'd be called A, B, C, which going from one ray to the endpoint to the other ray. You could also call it C, B, A. It doesn't matter. These two are the same. Or, if you want, you can just label something in the middle and then call it angle 1. Whatever you want. Okay. So, let's recap. So an angle is two rays meeting at an endpoint. So one important thing about angles that's important in geometry is that they can be measured. They can be measured. How can they be measured? Well, before we get introduced to that, we have to get introduced to a new postulate called the protractor postulate. Protractor. What's a protractor? Well, I don't have one on me, so I'll just draw one. A protractor is a semicircle. That's important, ain't it? It's a semicircle. And ooh, magical flying powers gave me a protractor. How cool. So, what's this protractor? This protractor, if I can show it, has numbers between 0 and 180. Or I don't know which way it's going, but it's one of them. It has numbers going from 0 to 180. Well, not 108, 180. So the protractor postulate, what is it? So, let's actually draw on the other side. So we have an opposite rays, two opposite rays, O, A, and O, B. They're opposite rays. Okay. And one other thing, AO and AB are congruent. Then we're gonna draw. So then we can draw any line from O, like this, OC. And OC, we can draw OC anywhere that we want, OC. And these angles can be paired with a certain number between 0 and 180. As the protractor postulate. So this angle, angle AOC can be paired with any number between 1 and 180. So let's apply this to a real protractor that I have in my hand. So this protractor I have has an endpoint in the middle. Because these two parts are congruent, this must be the midpoint. So you put your angle endpoint on the middle of your protractor. So right here is where you put your endpoint of your angle. Then you just line up one of the rays with markings on the protractor. So like so, let's say this one says 66. Then your angle measure is 66. That's pretty important, ain't it? It helps measure your angles. So you can construct triangles beautifully. Okay. So now let's talk about the part where it corresponds between 0 and 180. You can classify angles based on their length, mean measure. So let's start off with some names. This is very important names. So any angle between 0 and 89 degrees, 0 to 90, non-inclusive, is an acute angle. like this one. This is an acute angle because it has measures less between 0 and 90 degrees. If I take my protractor and I measure it, I get that this angle is about 35 degrees. 35 degree angle. So then what happens if it is 90 degrees? You get a right angle. And what's special about right angles? They are 1/2 of a protractor. Meaning they're called right. Because they are right in every way. Because they are right angles. Now numbers between 90 and 180, uninclusive, are obtuse angles. Because they are very big. They're super big. And then by the time you get to 180, you got straight lines. And this one would be called a straight angle. Because it's straight. And it's also an opposite ray, because remember, this is the end point. So it's an opposite ray. Then anything after that would be a reflex angle. Between 180 and 360 is considered a reflex angle. So yeah, that was all the boring terms they had to go over. This is very important to know your terms in geometry, because it can help you out later. So now let's go over some more postulates. The other one is the angle addition postulate. Angle addition postulate is where you can add angles. Like segments, this postulate says the same exact thing. If point B is in the middle of angle AOC, then AOB plus BOC equals AOC. Wait, they mentioned interior in this postulate. So let me repeat it again, so you can catch it. If ray OB is in the interior of angle AOC, then that means that AOB plus BOC equals AOC. Interior means inside, so it's inside the angle. Exterior means it's outside the angle. Or for anything that matter, because interior and exterior are not just geometrical terms. So that means I can use this to my advantage in geometry problems. So if this angle is 66 degrees, and this angle is about 270 degrees, then how big is the entire angle? This is grossly inaccurate, so what we do is we just add them up. 270 plus 66 equals to 336 degrees. Yeah. So this would involve a lot of equations you'd write in your math problems based on the simple concept that angle AOB plus angle BOC equals to angle AOC. And another important thing, the symbol. It's an angle. It's an acute angle. No matter what it is, it's an acute angle. Nothing else. There's no symbol for right angle. Only acute angles. So these denote any angle. And one final thing is that angles can be bisected. As in, let me show you a diagram. So we have this very big angle. We're going to call it a BAC. It's angle BAC. Let's say we have this ray AD. And it cuts the angle into two congruent angles. Congruent angles means they have the same measure, because congruent means same. Don't forget that. Congruent means same. So what does this mean? It's like a midpoint, but with angles. And because midpoints are also known as segment bisectors, if a line was to bisect it, then a bisector of a line that cuts an angle in half is known as an angle bisector. Bisector meaning cut in half. This is the part and 2. Okay. So that's it. So, in the next video, we'll talk about pairs of lines, unlike angles. So, I hope you enjoyed this video. Bye!